Hello there. Today I'll be doing something new. I'll use the credit card fraud detection dataset 2023 on Kaggle and also to leverage on Kaggle notebook. We'll do classification prediction today and we'll touch on machine learning models, um, logistic regression, support vector machine, rainforest, and ANN artificial neural network. It will be a lengthy session this time. We'll be walking through the Python codes. If you are gearing towards becoming a data scientist and Python code doesn't scare you, then here it is a good start. Okay, let's begin. Okay, we are now on this page on Kaggle. Uh, if you do a Google search on credit card fraud detection dataset, you should be able to arrive on this page. So here's it. Credit card fraud detection dataset 2023 uh, by uh, by him, which I have difficulty pronounce. I think it's Nidula. Okay, so he's the contributor for this dataset, and this is on Kaggle. You can download and run your ML program in your local machine, or you can click on the notebook here, and it will launch a new page. This is the editor. Okay, so you will come to here, then you just input all the codes and you can run it from here. I tried to do this on here, writing code line by line and recorded the video. It took a very long time, so I've decided not to do this. Instead, I've written all the codes here and I ran it. So I'm going to walk through my code with you uh, here. Okay, let's do this now. Okay, this is the generated code in the first cell by Kaggle. So if you click on the run, it actually prints out the location of the file with the file name here. Okay, this is important. Then I added a new cell, and this cell is just for all the libraries. So the important ones: Seaborn, TensorFlow, Matplotlib.pyplot, uh, TensorFlow sequential. This is for the deep learning ANN, and TensorFlow Keras layers. We will be adding a few layers, and we'll be going into brief. We'll touch on SVM, support vector machine. We also do standard scalar, another model, logistic regression, random forest classifier. Then we also use the trains test split function, and also we will print the confusion matrix, the classification report, and the accuracy score from the sklearn libraries. Okay. Okay, the first thing we just ignore and don't want the system to print uh, the error message. Okay. Uh, okay. Let's start by first reading the CSV file. So the first thing uh, I've created a data frame variable df and using PD, which is already defined here, pandas. So PD dot read CSV, then I'll copy this whole thing and I put in here, uh, and it will read. Then df.head will print out the first five rows of records. So as you can see, these are the column names. So ID, which we will not need because it's not relevant to the information here. It doesn't correspond to anything on this row except it just shows the index value for each column. Okay, so it starts from V1 up to V28 and then also the amount column. Okay, all these independent variable, which we always put them in a y. Oh no, in the x in the big X variable, and this is the output that we want, the class. So zero means is not a fraud. If it's a one, that means this row or record is actually a fraud. Okay, so class will have 0 and 1 value. Okay, and all these independent variable, there's some mechanics, some formulas. The models will try to understand and depict and to see what are which are the uh, variables that has a strong relations that can predict the class output. Okay, so let's. This is df tail is the last five records, so it's a one. Okay, same thing. Then I did total observation and the missing values. So df dot info. So we have v1 to the class. So from here you can know all this is actually either a float. Okay, the independent variables are all float data type, and the class, the output, that's the y, is integer. This one is 0 or 1. Okay, that's good. Okay, perfect, because everything is number and models love number. Okay, so this is also another checks on basic statistic df.describe. Okay, so we ignore the ID, so it's v1 again to v28 and amount and class also. So the count, that's the number of records. So 0 0.6 568,630 is same as this. That's correct. Okay, so we have 568 568630 rows. So everything here is the same. 586 630. So it compute the mean, compute the standard deviation. It also compute the minimum value, the 25% value, the 50% value, and the 75% value, and the max value. For this demo, we won't be using much on here, but if you are going into identifying outliers kind of stuff, you are plotting the box plot, uh, likely this will come into place. Okay, so df shape. This one is to identify the rows and columns. So same, we have this much number of rows and we have 31 columns. And we are also, this one is to check the missing values. So df dot is na and dot sum. So this one. So you can see it's zero missing value. Okay, so this is nice, perfect. Next, because we the independent variables are all just numbers and zero and ones. They are 1 to 28. That's a lot. And I didn't know what all these are for. Uh, but we can try to generate the number of percentage on fraud and no fraud. Okay, so this is the code. So 0 means no fraud and 1 means there's a fraud. Okay, so this is how it done. So I replaces the 0 with no fraud and 1 with fraud, and I plot, and this actually helps to plot the pie chart with the percentage value. So in this case, it's 50% for no fraud and 50% for fraud in this data set. And this is perfect because this is a perfectly balanced data set, which is good for learning for the start. Okay. Next, we printed also the um, let's see. Okay, next, this is the heat map. So heat map was printed using this code. Okay, so PLT, which was defined earlier in the library. Uh, SNS also defined earlier in the library. Let me check. So matplotlib, PLT, Seaborn, SNS. Okay. Okay, where are we now? Here. Okay. So so data frame CORR. That's the corresponding relationship. So uh, it's a cool warm display. Okay, adding the title which is here, then finally display the plot. Okay, from here you can see, okay, 1 is the highest value. That means that has the strongest relationship. So if you can see, this is the y-axis and this is the x-axis. So ID with itself, ID is always a 1. Okay, same here. So the class with the class itself is always a 1 because they are 100% related. Okay, so what we need to uh, do now is to find the highest value, highest independent uh, variable value comparing with the class. Okay, so from here you can see, okay, this is 0.1, not high, not high, not high, until we reach somewhere, we're beginning to see this V16, 0.57, ignoring the sign, plus or negative. Okay, so this 81, V14 is high, V12 is high, V11 is high. Okay, we'll take anything above 0.5. Okay, so we'll take this, we'll take this, we'll ignore this, we'll ignore this, ignore this, ignore this, we'll take this, we'll take this, we'll ignore this, we'll take this. Okay, so we'll ignore the ID. Okay, so we I also did another one that is printed one without using the heat map. So as you can see here, at class 1, at class there's the highest value. These are all the values that corresponds to the class variable. Okay, so you can ID we are not using, so ignore this. So zero point 0.4 is 0.73. V4 is 0.73. V11 is 0.72. Uh, so we'll ignore V2 until we ignore all this, and we will include. Remember, we're going to ignore the plus or positive sign. So the higher level here also include V14, V12, V13, up to here, V1. So we'll include this and this one. And to do that, we need to drop those variables that we don't need. Okay, so we don't need the ID, we don't need the class. This is because we want to define the X. Okay, X don't have a class, uh, don't have the Y, but the class is actually referencing the Y. Okay, so this is the thing that we need to drop. These are the columns that we need to drop. So we drop it and assign to X, and Y is just the class. The output, the models that need to learn from it to predict a value. Okay, after this I apply this formula. Y equals to value count. So from this we can see that it is perfectly balanced. So there's for zero for Y that has a zero value, and for Y there's one value. Both are exactly at 284,315. So perfectly balanced. Uh, so we, just to make sure, so I've printed also the columns for the X. Okay, I also did a scatter plot. So the formula is Seaborn from a Seaborn library pair plot. So for the all the variables in the X, so you will try to compare each other. Okay, so visually we can see there's no strong relationship between the independent variable. So we need to prevent multi-collinearity. Okay, so if there is, we need to handle them. But in this case, we don't. Uh, if you can see, the closest we get is this one, this one. So long as there's a straight line here, that's a strong relationship, but we don't have. But we this one we have something close. Likely because this is remember we have something like 0.49, 0.4. So these are likely those that are referencing the zero point 0.4 value. Okay, close, but there's a but it's not exactly perfect. The straight line, so something like this. Okay, this is likely from the zero point 0.4, which we will not consider. Okay, the next thing I used the train test split function. So following the SOP standard procedure, listing the variable. So I'll always have X in the cap and Y in the lower case. Okay, so we have this is standard line of code. So we have X train, X underscore train, X underscore test, Y underscore train, and Y underscore test equal. Then we apply the train test split. The X and the Y, remember, I've already assigned it here. Always, for me at least, X is always a cap, Y is always a small letter. So I've assigned X to this, and I've assigned Y from this. Okay, so then from here, throw in the X, throw in the Y, and test size, I've set it to 0.2, means 80% of the data set will go into the test, the train data set, the set, which is this one and this one. And 20% will go into the test set, which is this one and this one. Okay, so the test set will consist of the X test and Y test. Okay, I've also state the random state with a value 42, and also this stratify equals to Y. So done this, then also use standard scaler to scale the X and uh, the X train and test X train and X test. So X train, so scalar fit transform, and X test scalar uh, dot transform with the X test. So from here onwards, we're going to apply the machine learning model. So we'll start by logistic regression. So instantiate the model here. Then we perform a fit. Then we'll input the X train and Y train. We need to train it. So the model will train itself with the X train and Y train values. Then we use after that we do a prediction. Standard variable name that I always use, y underscore pred. Pred should be repeating prediction. So y underscore pred equals to model dot predict, and we are going to use the independent variable from the test set. Okay, that's the 20%. Remember earlier that we assigned. So we are going to do the prediction from the test set and not from the train set. Okay, this is good. Okay, so then we print the accuracy score and pass in the uh, prediction value uh, from the test set, and we also pass the test set uh, y value so they can they can compare and compute the accuracy score. So for the logistic regression, the accuracy is 96%. It is very high in real life. But for because this data set is good, it's clean, it's balanced, so it is very straightforward. Okay. There's also no missing value, there's no null value. Okay, so it becomes a lot easier. Okay, we also wait, let me see. Okay, I've also come up with uh, okay, confusion matrix here is also printed out. So we plotted the heat map, okay, with prediction label and true label. Okay, what does this means? This means okay, the system, this model correctly predicted uh, 500 and 553,408 records correctly predicted that is fraud, and it turns out that it is a fraud. So it is correctly predicted which is a fraud. Okay, and it actually turns out to be the fraud. And this model predicted five 55,570 that is no fraud, and it turns out correctly it is no fraud. Okay, so this is good. This is the correct and accurate prediction from the data set. Okay, and uh, the model predicted 1293 is a fraud, but it turns out that in the data this is not a fraud. So this is an error. And also same, the system predicted 3455. This is no fraud, but in the actual data it detected of this prediction 3455 is actually a fraud. Uh, this falls down, this goes down. Okay, this is the same thing. I just print it without the these boxes here, just the label. And that means to say that for 0 and 1, for 0, printing out 0, the F1 score is 96%. The 1 is also 96%. Okay, quite balanced here. I mean, you can see there's thousands, also this one is thousands. And the accuracy is 96%. Okay, so this is logistic regression. So we now head to random forest. Okay, the instantiation is slightly different with different parameters. So estimator's value I set it as 300. So maximum depth, because a rainforest there's a tree, so it just, so you need, in this case I set to none. You can set to 3, 5 or whatever, and try it out and see the results. Of course, it may, the interpreting this code may take longer if you put it as none, which I did. So same random state I put as 42 always. Okay, you can change this. 1, 3, 7, up to you. Okay, so the next is the prediction. Same thing. So predict the y value using the test dataset, the independent variable. Then we print the accuracy. In this case, this is 99%. Then we plot the confusion matrix. So here you can obviously see uh, the wrong prediction is low. So wrongly predicted, no fraud, and it's actually a fraud. It's only one. Wrongly predicted, it is a fraud, and it actually is not a fraud. It's 51 only. If you compare this and this, it is a huge difference. So random forest actually performs better in the prediction, and of course this is all higher. This is 56,000, 56,000, 57,000 if you round up. So compared to this, see, this is about 1,000 a thousand points higher. This is also 53 2009 or something, close to 3,000 higher in value. So this is better. Okay, so 51 wrongly and 1 wrongly. So this is it gives a F1 score of 111, which is 100% in accuracy. But in detail, is actually not 100% because there's still one wrong here and 51 wrong here. So it should be, ideally should be 99%, 99 point something percent. But I believe it's a round up number. Then we go into SVM, support vector machine. So instantiation also different, uh, but I've applied the same, and I've applied the same random state value. Okay, so we also do a prediction. That's this, and then we print, and then I print the accuracy score. This is 98%. So if you compare this result, uh, the number of wrongly computed value, this one is in thousands, this one is in close to thousand, 900 over that. So it's better than logistic regression, but not not better than rainforest. So rainforest here is only 51 and 1, the error that they made. Okay, but and logistic regression, let's go. It's actually 3005, 1003. So okay. Compared to logistic regression, 3005 here and 1003 here. So this fares better than logistic regression. Okay. So this is the SVM, and the result is 98%. And now we go into something very interesting, at least to me. Uh, this is the basic in deep learning. So it's artificial neural network. So this is slightly different um, from this SVM, from rainforest, from logistics. It is it is at a different level. Okay, and So we'll start by instantiating the model using sequential, which we have defined in the libraries above. We can add the base model. Then after that, we'll introduce the hidden layer. So this is the first layer, then the hidden layer, then the output layer. In this case, the output layer can only be one because it's just class 0 or 1. So it's just one value. Okay. And we'll start by activation with using relu, uh, and also the hidden layers relu, and for the output layer we'll be using sigmoid. Okay, we can play around with this. We can have a few more layers. We can start off with instead of 16, we can start off with 32, 16, then introduce one more 8, then 1, or a lot of different combination. But for this case, I'll stay with 16, 8, 1. Okay. Then we compile. So optimizer using Adam, uh, and for loss is a binary cross entropy. Matrix is accuracy. I think this is quite common. Um, then also introduce variable early stopping. Uh, there's a there's a parameter here. Patience can play around with 10 or 15, but for this case, I'll stick to just 5. Okay. Then train the model. So we pass in the X train, the Y train, the X test, the Y test for the validation data. Then the epoch 50 can set it to 100. I, and you can set it to maybe 25 uh, or 75. Uh, you maybe you will be able to see some difference. Then the batch size are set to 32. Okay, then ignore this. Then it will run. It will try to run for up to 50, but because there's a early stopping here to avoid overfitting, so it has stopped somewhere at 39. Okay, so this is a very good value here. You can see from the start the accuracy here is 95%. The loss is 0.1. Then the value accuracy is at 97%. The value loss is 0.1. Okay, as it goes down, it ends up at the end value is 99% for the accuracy, zero point 0.0 for the loss. Value accuracy also 99%. Value loss 0.0%. Okay, that's good. So printed the accuracy at 99 and 99%, and also wait. Then we go into the confusion matrix. Okay, for confusion matrix. So as you can see, uh, correctly predicted for fraud is 56,447. For correctly predicted for not a fraud is 56,360. Quite balanced. Okay, and incorrectly predicted it is a fraud, but it's actually a not fraud. So it's 503. Incorrectly predicted it is not fraud, no fraud, uh, but it's actually a fraud is 416. Uh, but you can see here, this actually fares not as good as random forest, but you cannot compare. Okay, random forest is here 51 and only one, the error so low. Okay, and this is 500 and this is 416, and this is better than the rest except for random forest. It's better than logistic regression is better than SVM. Okay, but because I have not tuned this, I have not played around with uh, this epoch and these hidden layers and the value here. So i- I'm this is not optimized. Okay, so if you done that, it maybe can come close or become better than random forest. Okay, but it is a good result at 99%, 0 and 1. Okay, I actually like this. Uh, and we have come to the end of today's session, and I hope this brings value to you, especially if you are gearing towards machine learning. Okay. This is a very simple, straightforward data set, but it's good for trying out and to start to learn from it. Uh, and okay, if you like this, if you uh, maybe if you like this, please like this video and tell your friends, colleagues about this uh, and subscribe. We are still growing, and I'll try to bring you more AI, ML videos, and also not so clean data that we can do some sort of cleaning. I think that's important because in real life, most at almost all times, datas are complicated and not clean. Okay, so stay tuned. We'll be also going into Power BI and Microsoft Excel when necessary. Okay, stay tuned and see you and thank you.